Hello everyone. For today's topic would be edge computing. We'll try to understand theoretically what edge computing is actually. For today's table of content would be we'll start with cloud computing and let know the limitation that we have in cloud computing, and then we will move forward toward edge computing. So as we all know that cloud computing is an infrastructure and software system that allow the access to shared network storage server and application over the internet. With cloud computing, user can access database resources via internet from anywhere for as long as they want without worrying about the maintenance and managing actual resource. But the limitation with the cloud computing is the latency. Although cloud computing is very fast, but in system where time is very crucial. Let's suppose self-driving car. In there, the time is very crucial for taking decisions with the data collected by the sensors of that car. So we need to process that data in the car itself so that it can take decisions very fast. For that reason, we have the limitation in the latency for cloud computing. Then we comes to bandwidth. If we are sending too much of data collected by the sensors, then we will be sending too much of data to the cloud, and this will consume a lot of bandwidth, which will uh, create the bandwidth, which will eventually take more processing time because we will have so much data. That's why bandwidth is also a limitation for cloud computing. And as far as availability, cloud computers are always available, but it depends upon the network the sensors are using. If there are some problem in that, then cloud computing will not be able to connect with the cloud. And in cloud computing, energy is also a very limiting factor because there is so much of processing will be happening at cloud, and it will consume a lot of energy. Now moving forward to edge computing. Edge computing is nothing. It is just a distributed technology architecture where the client data is processed at the periphery of the network as close as to the originating source as possible. In this, we what actually try to do is that we try to process the data generated by the devices, edge devices, at the very closest possible so that we can have very low latency. Need for edge computings are the power the next industrial revolution, transforming manufacturing and service, optimizing data capture and analysis at the edge to create actionable business intelligence, create a flexible, scalable, secure, and more automated technology systems and core business process environment developed due to the exponential growth of IoT devices which connect to the internet for managing information over cloud, promote an agile business ecosystem that is more efficient, perform faster, save cost, and is easier to manage and maintain. Edge computing terms and definition. What are the main terms in terms of edge computing? So first is edge. It depends on the use case. Like for telecommunication, it could be our cell tower or phone. Similarly, for automotive, it could be a car. For manufacturing, it could be a machine. And for information technology, it could be a laptop. Edge device is a device which actually is producing the data, collecting from its environment and delivering it to the network. Edge gateway is the buffer where edge computing processing is done. The gateway is the window into the environment beyond the edge of the network. Edge servers are the computers located in a facility close to the edge devices. These machines run application workload and shared service, so they need more computing power than edge devices. Edge node is a computer that acts as an user protocol for communication with other node in cluster computing. Any device, server, or gateway that perform edge computing. A public or private cloud that act as a repository for containerized workload like application and machine learning model. The cloud also host run apps that manage each node. At cloud, what actually happens is all the data that we send to the cloud for the final processing, and there we have heavy machine learning models and applications which process those data to take actionable decisions which can be used in the taking decisions for that particular use case. Internet of Things and Edge computing. The Internet of Things refers to a system of interrelated, interconnected objects that are able to collect, transfer data over a wireless network without human intervention. In IoT, with the help of edge computing, intelligence moves to the edge. That means we can take the decisions at the edge itself. There are various scenarios where speed and high speed data are main component for management, power issues, analytics, and real-time need helps to process data and edge computing in IoT. In architecture of edge computing, as we can see, we have edge devices which collects data. Then it uses a network gateway through which it sends its data to the nearest node where it can be processed. And then decisions also taken at this node and sent back to the edge devices. But the main data which are processed and find useful, they are being sent to the cloud for the final process. How edge computing works: a network of micro data center that store or process critical data locally and push receive data to a centralized data center or repository of cloud storage. Typically in IoT use case, a massive chunk of data goes through the data center, but edge computing process that data locally results in reduced traffic in central repository. This is done by IoT device transferring the data to the local device, which includes storage, compute, and network security. After that, data is processed at the edge while another portion is sent to the storage repository or central processing in the data center. Example would be a CCT system. Consider a building secured with dozens of high definition IoT video cameras. These are dumb cameras that simply output a raw video signal and continuously stream that signal to a cloud server. In the traditional cloud computing system, on the cloud server, the video output from all the camera is put through a motion detection application to ensure that only clip featuring activity are served to server database. This means there is a constant and significant strain on the building internet infrastructure, and significant bandwidth gets consumed by the high volume of video footage being transferred. But in the edge computing system, now the motion sensor computation is moved to the network edge. Each camera uses its own internal computer to run the motion detecting application and then send footage to the cloud server as needed. This results in significant reduction in the bandwidth use because much of the video camera footage will never have to travel to the cloud server. Advantage would be speed, as edge computing has the capability to increase network speed by reducing the latency. It greatly reduces the distance traveled. It should travel by processing the data closer to the source of information. Scalability: the edge can be used to scale your IoT network without needing to worry about the storage requirements. Reliability: edge computing handles reliability part very well, since most of the time the edge computing does not depend on internet connection and server. It offers an uninterruptible service. In terms of security, the information present on the cloud has the tendency to get hacked easily. Since the edge computing only sends the relevant information to the cloud, this can be prevented. Cost effectiveness: using edge computing for IoT allows users to reduce the bandwidth and data storage requirement and replaces data center with device solutions. So overall cost get reduced. Disadvantage: security. Due to the fact that data processing takes place at the outside or edge of the network, there are often risks of identity theft and cybersecurity breaches. Incomplete data: edge computing only process and analyze partial set of information. The rest of the data is just discarded. More storage space: edge computing does not take considerable higher cost higher storage space on your device. Investment cost: implementing an edge infrastructure can be costly and complex. This is due to their complexity, which needs additional equipment and resources. Maintenance: in edge computing, there are more various network combination with several computing nodes. This require higher maintenance cost than a centralized infrastructure. Application use case, manufacturing. An industrial manufacturer deploys edge computing to monitor manufacturing, enable real-time analytics and machine learning at the edge to find production error and improve product manufacturing quality. In farming, using sensors enables the business to track water uses, nutrient density, and determine optimal harvest. Data is collected, analyzed to find the effect of natural factor and therefore produce good yields. Improved health care. The healthcare industry has dramatically expanded the amount of patient data collected from devices, sensors, and other medical equipments. That enormous data volume require edge computing to apply automation and machine learning to access the data. Traffic management. Edge computing can enable more effective city traffic management. Example of this included optimizing bus frequency given fluctuation in demand, managing and opening and closing of lanes, and in future managing autonomous cars flow. Smart home. Smart home rely on IoT device collecting and processing data from around the house. As an example, the time taken for voice-based assistant device such as Amazon Alexa to respond would be much faster. Conclusion. So edge computing is very promising and has found many useful applications. Bringing computation to the network edge minimizes the amount of long distance communication that has to happen between a client and server. However, there are still many challenges faced by the community ranging from fundamental technologies to novel application scenario and potential business model. Edge computing gained notice when the rise of IoT and the sudden glut of data such devices produce, but with IoT technology still in relevant infancy, the evolution of IoT devices will also have an impact on the future development of edge computing. Thank you.